From a young age, I've always had a very curious attitude, always asking questions, seeking answers, and this led me to become a scientist. During my university years, the debate over animal-free testing gained significance. And although I wasn't entirely against animal testing for human health, I began to wonder if there was a better option.
Hey, Doc. Why did you start thinking about better options than animal testing?
I started working with human stem cell-based technology, and I realized its potential to yield more robust and accurate results, while also saving countless animals. Animals have intrinsic genetic differences from humans, often leading to unreliable outcomes. During the COVID-19 pandemic, for example, SARS coronavirus 2, the virus responsible for COVID-19, jumped from bats to humans, causing very severe symptoms in humans while not causing any harm in bats. This clearly shows that viruses behave differently in animals compared to humans. And despite this, antiviral testing still heavily relies on animal models, leading to a 95% failure rate of antiviral drugs in human clinical trials. To address this issue, instead of using mice, I work with advanced human models.
What are those tiny things? They look like mini versions of us.
These tiny, self-organized, three-dimensional structures are called organoids. Organoids are made from human stem cells and replicate the complexity and functionality of human organs. For instance, airway and gut organoids display different cell types and important characteristics like beating cilia of ciliated cells, while brain organoids show layered cell structure that mimic the complexity of the human brain.
So, you're using these organoids to give us viruses a real challenge?
Viruses are parasites that cannot survive on their own, but need a host like us. To test the efficacy of antivirals, it is crucial to mimic the human host and infect these human models with viruses that are circulating in the human population, not viruses that have been grown in the lab since the 60s, which are different from what is infecting us today.
Where do you get the viruses to test on your organoids?
Working in a hospital provides me access to clinical material from patients, like feces or respiratory swabs, allowing me to isolate different viruses, such as influenza, SARS coronavirus 2, enterovirus, RSV, or human cytomegalovirus, which cause severe outcomes in patients.
Why is your research so important in fighting us viruses?
Emerging viral infections are a global threat, and the COVID-19 pandemic emphasizes the urgent need for effective antiviral treatments. By creating advanced human organoid models and infecting them with human viruses, my research is advancing antiviral testing. While traditional animal testing only show 5% success rate in humans, our human-based models aim to significantly improve this rate, accelerating the successful delivery of effective antivirals to patients.
Can your organoids help make treatments just for specific people?
My research holds great potential in precision medicine. By isolating the virus and the stem cells from a patient suffering from severe viral infection, we can test personalized treatments. Human organoids offer a powerful solution to improve the predictive value of preclinical antiviral testing. With this technology, I can bring antivirals to the market faster and more efficiently, ultimately saving lives. Let's work together to make animal-free research the future of science, enhancing human lives by saving animals.